Hey guys, and welcome to my picoCTF series. This is challenge number 7, reverse engineering transformation. Let's just jump right into it. It looks like it's going to be a little bit more difficult than the ones we've done so far. There's not as many solves and it's not incredibly popular. So let's have a look. I wonder what this is. Okay, so this looks like it could be maybe Python. Let's download this file and see what it is. Nothing sensitive here. Probably not. Okay. picoCTF. Make the transformation. Download. And let's have a look. Oh, look at that. Oh, blimey. Okay. So we've got some interesting looking characters here. So this is probably the flag, which has been mangled in some kind of way. Let's oh, okay. So it looks like what's happening is it's bit shifted. Okay, so yeah, based on this, it looks like there's been some bit shifting. So I think we can probably, I don't think we need to use this code. I think we can probably do this without using the code. So is there a bit shifting operation? Bit shift left. Let's have a look. It might be a bit shift right, to be honest. Bit shift right, let's see. I'm gonna have to, because it's like the output's not ASCII, I'm gonna specify a file as the input. Okay, let's just do that. picoCTF transformation inc. Okay, so we bit shift. We only bit shifted by 1. We want to do by 8, I think. Oh, it didn't work. Okay, let's try bit shifting left. Nope, that didn't work either. Okay, so I was incorrect in this case. Close but no cigar. I mean, that looks really close, doesn't it? Okay, so I should probably explain what bit shifting is. So basically, it helps to draw to kind of show this. So you have computers only know about 1 and 0. So you have to represent, everything is represented ultimately in 1s and 0s. And if you have, say, so we know that a capital A in ASCII is 65, right? So like we have A is 65 and 65 cannot be represented on a computer in decimal, it has to be in binary. So what we can do is if we create a new file, we have 1, 2, 8, 64, 32, 16, 8, 4, 2, 1, 1, 2, 2, 5, hang on a sec, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is very simple. So this is very simple, basically. In order to create A in 1s and 0s, we have to use binary, and binary is just it's just a way of representing numbers. So you have decimal, which is one way of representing numbers, and you have binary. You also have stuff like hex, which uses 16 different symbols to represent numbers. So if we want to do 65, we just have to do this. So this is 65 because we've got a 1 in the 64 column and we have a 1 in the 1s column. So 1 plus 64 is 65, right? And what you're doing when you're bit shifting is you're basically moving these you're moving all of the how can I explain it? So with bit shifting, if you bit shift right, then this becomes a 0 and this becomes a 1, right? And then this becomes a 0. I think that's how that works. So you're shifting right by 1, or you can shift left by 1, and this obviously changes the value. So this now becomes 32, right? So what I was thinking is with this challenge, let's have a look. picoCTF transformation. So let's take the first character, which is this, and let's see what it is according to CyberChef. Text, decode text, maybe. What does that do? Oh, okay. So yeah, that's the one thing I'm not sure about. I don't know what this is not ASCII, right? It's probably UTF, but what UTF? UTF 16 or 32 or what? Maybe UTF 8. I really want like the hex representation, I think. So from 2 hex, yeah, let's do 2 hex. Okay. So, okay. How many bytes? Yeah, that's the other thing I'm not sure about. I'm not sure how many bytes per character there are. You know what? Let's just have a look at this. Oh, hang on. Oh, it looks like you're shifting left by 8 bits, and then you have to add the second character. Okay. So can we just do, I wonder if, you know what, let's take this code and use it. I don't know if this is to encode or to decode. So we might have to, this is like shifting left, maybe we have to shift right. Let's find out. Run Python. Let's try with a character like, can we do something like that? Oh, God. Okay, hang on. A.join char. Why is this? Yeah, there's like an extra. Oh goodness. Okay, I need to like break this down. Okay. Transform. Join char. Okay, and then we're adding that. Yeah, simple enough. Okay, right. Okay. So do we just add it to the end? Is that gonna work? Maybe. Let's try. Oh yeah, okay, so the other thing we need to do is set the flag. So can we just, we might not be able to do this like this, but maybe we can. I want to, what I'd like to do is to open the enc file here. So maybe we can, okay, hang on a second. Python open file, read file to variable. Okay. Read file into a string. Yeah, I don't want to just paste it to the shell because it's not, I don't know if, I'm not sure what, if it's like UTF-8 or something else, and it might not copy correctly, so you really want to just read the file. into a variable, and then you know that it's probably going to be correct. Okay, so let's do that. I need to create a Python script, really. That's fine. Okay. So writing a Python script. We're going to open the enc file, which is here. And we're going to store it in a variable called, I don't know, enc. And then we'll print it just to make sure it's working. Okay, that looks good. So now what we can do is we can, using this, let's do that, print that. Is that going to work? I don't know. Let's find out. Okay, that's fine. Flag is not defined. Okay, yeah, so let's define the flag. And I is not defined. Yeah, that's okay. I equals 0. I'm just, at the moment, I'm just testing. I don't want to like commit right now. Not in range. Okay, that's fine. Let's bit shift the other way, just in case. Okay, not helpful. That's a shame. Chart arg not in range. Okay. So interesting. Oh, yeah, so this, I think this is encoding, right? So let's just go the other way. So we need to bit shift right, and then we need to subtract rather than add, right? No, it doesn't like that either. Poop. Or maybe it has to be I minus 1. No. Okay. Okay. Okay, let's print. I want to print the first character, just the first character, right? And I want to see what the value is of the first character. Char is not defined. Oh yeah. Oops. String cannot be interpreted as an integer. Okay. Let's just print out the value like this. Okay. Why can't I just do that? Star cannot be interpreted as an integer. Right, okay. Okay, so let me see what is odd in Python. Okay, so this is definitely a Unicode character. Fine. I need a Unicode table. So Unicode table. This table is a bit bigger than the ASCII table because it includes symbols and characters from different languages. So what I'd like to see is I want to be able to specify. Let's have a look. So P, for example. So we know that the first character is probably P, right? At decimal, that's 112. Still 112. Okay. So how do we need to get from this number to 112. So how do we do that? If we bit shift this way, what happens? String and int. Oops. That's probably why. Okay. Whoa, that's a bigger number. We don't want a bigger number, we want a smaller number. Ah, here we go. Right. Okay. So this looks good. So what's happened is the number that we saw before, this number is that's the numeral representation of the first character, and we bit shifted right by 8 bits. Yeah, so we made the number smaller, a lot smaller. So if we look at this again, we can see here that okay, so this is basically the encryption method. So we need to do like the decryption method. So let me just check that the next character is actually legit. This should be an I, right? 99. Yeah, I think that's right. Oh, no, it's not. Hang on, what's going on there? Uh, 99, what's 99? C. Interesting. Why has that happened? Where's the I? That's strange, isn't it? What's the third one then? 67. I'd expect that to be a C. It's not. 67 is like a okay, that's right. So it's almost like we're missing. It's like we're missing a character. It's gone. So it's P. Okay, let me just. So let's print out the. Can we do that? Yeah. Okay. Let's print out the character for each one of these numbers. Yeah, we're missing some things here. We're missing some characters. It should be P-I-C-O like that, but we're missing I and we're missing O. Okay, interesting. And that's because I wonder if it's because when we're bit shifting, are we losing some information? We might well be. Yeah, so what they've done is, I think each each character encodes two. Each UTF character is like 2 ASCII characters, right? So what we need to do is, that's the first character, and then the second character is something like, so we're bit shifting right. We still need to bit shift right. Maybe we need to bit shift more though. Maybe we need to do like that. No. I need to think about this. So, let's take this again. Let's not bit shift this time. I just want to see this number, and then with this number, I want to see it in. I want to see what it looks like in binary, right? So let's get rid of that. Let's get rid of that. Binary. 2 binary, yes please. Okay, right. Okay, so 1, 2, 3, 4, 5 bytes. Oh no, no, that's not what I wanted. Let's go to hex. So yeah, what it's done is for each it's treating it like a string, and it shouldn't. So let's do to hex instead. Get rid of that. but I don't, no, this is wrong as well. There's no delimiter, right? Oh yeah, that's bytes per line. Okay, I just want to convert to binary, but like the whole number, not each individual character. Decimal to binary, let's try that. Enter the decimal number, convert. Okay, cool. So we have a binary number. So we have 1, 2, 4, 6, 8. So that's that's one of the characters. So what I'm thinking is, can we take this binary number, we put it here, 1, 2, 3, 4, 5, 6, 7, 8, and then we have 2 binary numbers, right? So if we swap this around, 105, okay, that's 105. What's this one? 112. Yeah, 105 and 112 sound like they could be right. 112, and I'm hoping this is 105. Yes, okay, good. So what we need to do, what's happening is we have basically 2 ASCII characters in 1 UTF character, and what we're doing is we're bit shifting. When we're doing the bit shift, we're almost removing some information, right? Because so this is P, I think. Let me check. 112, right? Yeah, 112. So what we need to do, so what we're doing in the first instance is we're bit shifting. So we have this as the first character. We're bit shifting by 8 places, which kind of basically, it means that this like this byte is being shifted over, but it's removing the second byte, which is the I. Okay, so what we need to do is we have to print the first character of the flag again, but this time we need to mask it so that we only extract the first 8 bytes and not all of it. So to do that, we can, I'm pretty sure we can do like a bitwise operation. So if we do like solve, if we do this, for example, so we don't want to bit shift, we just want to do how do we do this? We only want to print 1 byte. We don't want to print the whole lot. So can we bit shift? We can bit shift. No, we don't. Do we have to bit shift? I don't think we do. I think we can just do a mask. How do we do that? Because we only want to. Okay, so what I'm thinking about is like a bit mask is where we have this binary number, right? Let me swap it back. Convert binary number. Okay. 1, 2, 3, 4, 5, 6, 7, 8. We only want the second byte. Okay. So we can do a mask where it's not an or, it's not an and either. What is it? It isn't. I want to like chop off the first, like this byte, but I can't remember how to do it in Python. How do I do that? Oh, could we subtract? Oh, that's what they're doing. Yeah. We can subtract. Yes. Okay. We can subtract the first byte from, okay, so we have, so the first time is, that's fine. The second time we want to print it, but we want to subtract. Oh, this is, it's kind of complicated, because we have to subtract odd flag 0, but we need a mask. Okay, so we need to do something like this. Minus org. I think it's that. I think that might work. I'm not sure though. I'll have to explain this when I've done it as well. Yeah, this is complicated. It's more complicated. Okay, let's try that. Invalid syntax. Okay, I need to do, so Python bit mask. How does it work? Okay, it's just one ampersand, not 2. That's actually not going to work, but I just want to see if it, okay, cool. I think we actually have to do that. No. Minus. Oh, hang on, no. Oh, can we just we can just do this, right? We bit shift it 8, we go this way and then we just come back, right? Can we do that? No, we can't. Okay, don't print the character. I want to see what the number is. 0. Oh dear. Okay. I thought that would work actually. $105. Oh, that looks better. That looks better. I'm going to have to explain how this is working. Okay, that looks good. So now we need a for loop, right? For I in len of flag. And this probably won't work, but maybe it'll work, but it might crash at the end. Let's have a look. Int is not iterable. Oh, for goodness sake, I'm really range. That's it. For I in range 0 to the length. Okay, cool. Yeah, let's try that. Whew. Oh god, I'm so glad that worked. Okay, end is nothing. So I need to explain what the hell I'm doing. So let me do that in a sec. Well, hey, we have a flag. 16 bits. Okay. Okay, so what I'm doing is, so this first line, we can remove all this stuff. Let's just make sure that works. That's fine. So the first line, what's the first line? What's this line doing? Line number 7. We're bit shifting. So we have the first character. Okay, the first character is where is the this? So we understand that the first character as an integer, the first character is 28,777, right? And you can't represent this integer in 1 byte. You have to do it in 2 bytes. So we have 2 bytes here. So we have like this, right? And I was thinking 1, 2, 3, 4, 5, 6, 7, 8. My spidey sense was tingling when I saw this. This to me made me think that we need to do some kind of bit manipulation. So you have 8 bits to a byte, and this is 1 bit, this is 2 bits, 3 bits, 4 bits, and then we have a byte. Oh, hang on a sec, something's wrong. 1, 2, 3, 4, 5, 6, 7. That's wrong. Oh, hang on a second, something's wrong. Let me find that again. Let's delete that. 1, 2, 3, 4, 5, 6, 7, 8. Interesting. What? 1, 2, 3, 4, 5, 6, 7, 8. Not sure why. Hang on a second. Something's gone wrong. Something's weird here because 1, 2, 3, 4, 5, 6. Okay, so there should be 15. So the reason that's happened is because there should be like a leading 0. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Whoa. No. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. What is going on? I'm doing something silly here, guys. Something silly. There we go. Finally. Okay. So we have. So this is really 28,000 has to be represented using 2 bytes, basically. And I was thinking maybe these 2 bytes could be, maybe they're actually P and I, right? So this, for example, let's just put this in here. So we have this number. We want to go from binary, right? From binary. Right, so that's a P. Okay. And then the second byte is hopefully an I. Yeah. You see we have the I. Okay, so now what this means is that so although the encrypted file kind of looks like this, so this character is 2 bytes, this character is 2 bytes, they're all 2 bytes, right? So if we can like extract if we can extract each byte and represent it in as an ASCII character, then that's how we get this output, right? So let me open this again. So this line here, line 7, what it's doing is on the first character, it is bit shifting by 8, right? So what it's doing is it's bit shifting by 8, so it's going like this. It's bit shifting by 8, and it's removing this, and you're left with just this, right? So you have 8 bits instead of 16, and this is fine. You can now take this and convert it into P, and that's all that first line does, right? The second line's a bit more complicated because what you need to do is you need to extract this byte, right? So how do you extract this byte? I was thinking at first you could do some kind of mask, like I was thinking it can't be an AND. So there's different bitwise operators. You have AND, or, XOR, more. Like there's many. And this is basically how computer, this is really basic stuff. Like bitwise operators is something that you should look into because it's very fundamental to computer science. And I was thinking initially, like, how can I use bitwise operators to extract just the second byte? So I was thinking about, in my mind, I was thinking, can I do like an AND? So with AND, I need to talk about this briefly. So with AND, you have if you have so this is, so we have like input A and input B, right? And then we have an output C. If input A is 1 and input B is 1, with an AND operator, C would be 1. Okay, the output would be 1. If however A was 1 and B was 0, then the output would be 0. And that's because both A and B, both inputs, have to be 1 in order to get an output of 1. If only one of them is 1, then it's not 1. It's not A and B. It's A and then not B. So you won't get the correct. You won't get 0. Sorry, you won't get 1 as the output. If however you did like, if you use a different bitwise operator like OR, we have A, B, and C. If you had like this, that would, if you had A and B was 1, then C would be 1. The output would be 1. Or if you had like 1 and 0, then the output would be 1 because it's A or B. If A or B is 1, then the output is 1, which is different from AND. Like with AND, it has to be A and B, right? But if you had like 0, 0, you would have 0 for the OR because A or B don't equal 1, so you're not going to get an output of 1. So I was thinking like what you can do is you can apply a bitwise operator. So I was thinking like, could we do, if I had like zeros here and ones here, could I get the output which was like, could I get an output where this is always 0 and this would always be like this, right? And I couldn't figure it out. There must be a way to do that though. Oh, it is an AND, actually. It is an AND. So another way we could do this is by, we don't have to subtract. Yeah, so the way I've done it is it's a bit convoluted. I'm bit shifting right by 8 bits. So what's happening is with this line, we're taking this output, we're taking this character, we're bit shifting to the right by 8 bits. So we have this, and then we're bit shifting that to the left by 8 bits. And when that happens, you end up with this, right? And then finally, I'm subtracting the original. So I'm basically, you take the original and then you subtract this bit shifted right, bit shifted left number. So it's kind of like this, and you end up with something sensible. But this is actually a silly way to do it because, so this is the answer you get, which is, you know, it's the answer we want. We want the second byte, right? We want this byte without having this. So this works, but it's not a good way to do it really. Like the AND operation would have worked. So what we can do instead is we can probably just do this. Do we need to subtract anything? I don't think so. Hang on. I think that'll work. He says. Yes, that works as well. So the reason, this is a lot simpler. Like this line is silly. This is easier to read and it's easier to understand. And all I'm doing is I'm applying a bitwise operation, the bitwise AND operation, which is indicated by this ampersand. So we have like the second byte. This is the second byte. So we want to extract this, right? So what I'm doing is I'm applying a, this is a bitwise operator. This is an AND bitwise operation, right? So if we do that, then we know that 0 and 0 is 0, 1 and 0 is 0, 1 and 0 is 0, 1 and 0 is 0. These are all 0. 0 and 1 is 0, 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1, 0, 0, 1, right? So we are in essence extracting what we want by having this bitwise AND operation. If I had done something different, like, so what's the biggest, if I'd done, is it 65, I think it's, if it's 2 bytes, I think it's 65534. I think that's equivalent to this, right? So if we'd done that, we would get the original output. So this will look, this won't work, basically, yeah, which is fine. But if we, yeah, let's just change it back to 255, which is basically, 255 is all ones, like 8 bits worth of 1. Let's do that again, and we have, yeah, the answer. So I'm going to submit this now. This has already been a long video. I apologize that it's not being quite as clear as the other ones, but I am, when I do these flags, when I do these challenges, I am going in completely blind, and yeah, that's done now, so that's good. I hope you've enjoyed the video. If you have any questions, please let me know. Please like and subscribe, and you'll see me in the next video.